In section 1.3, we're going to go over linear functions, and I know that you are all familiar with lines and their graphs, but there may be some vocabulary or symbols in this section that you haven't seen before. Basically, a linear function can be written in the form f of x is equal to ax plus b, where a and b are just real numbers. Now, a linear function, if we graph it, will be a line, which is why it's called a linear function. And when we graph lines, there's some very important points that we want to find. And basically, those would be the points, if they exist, where the lines cross the x or the y axis. But first, I would like to introduce you to what we call the zero of the function, and that may be new to you. Basically, when we're saying the zero of the function, we're saying where is f of x equal to 0, or where is y equal to 0, because remember, we can always replace our function notation with y. So where f of x or y is equal to 0, and here it would be at some point a, and that would be an x value. So if that a value does exist, then the point a comma 0 will be an x-intercept. So again, a comma 0 is an x-intercept, it's a point, but the actual 0 of the function would just be the a value. So let's say we have a linear equation of the form, and here I'm going to use y instead of f of x, y equal to ax plus b. For one, it's simpler notation, and two, some of our lines may not be functions, but they will be linear equations. But to find the x-intercept, you're always just going to let the y value be 0, and then you would just solve for x. To find the y-intercept, you let x be 0, and you solve for y. Example 1 asks us to graph the linear function f of x equal to 2x minus 4. And we're going to identify the intercepts and the 0 of the function. Again, if they exist, they may not. So here, I'm going to replace the f of x with y. It's just simpler notation. And to graph, I'm just going to make myself a table of values. So I need at least 2 points to graph a line. Since the x and the y intercepts are the most important points, and they're actually the easiest points to find because one of the values will be 0, at least one, maybe 2 of the values will be 0. Then it's simpler for me to just find the x and y intercepts by first plugging in 0 for x, solving to get negative 4 for y, and then when I graph 0 comma negative 4, I can see that that's on the y-axis, and this is my y-intercept. Again, because it's intercepting the y-axis. So my y-intercept, and I'm just going to abbreviate that int, is going to be the point. It's not the value negative 4, because it is a point. So you need to write it as an ordered pair 0 comma negative 4. If I put in 0 for y in the equation and solve for x, I get x is equal to 2. So this point 2 comma 0 is going to be my x-intercept. As you see from the graph, at that point we are intercepting the x-axis. So x-intercept is going to be the point 2 comma 0. And now, since my y is equal to 0 when x is equal to 2, that a value that we're talking about for the 0 of the function is just going to be 2. So that would be our 0. So the 0 of the function is just a value, but the intercepts are points. Okay, so the 0 of the function is simply the x value for the x-intercept. We found all the items that we needed to find. I'm going to finish graphing my equation. I just need 2 points to graph a line, but I'm going to pick a third point just to check my math. I'm going to pick some small x value that I haven't used yet. What about 1? So if x is 1 in the equation, we get y is equal to -2. And I can see that all 3 points line up, so my math is most likely correct. And I can finish this off by kind of drawing a line that looks sort of straight. I'm horrible at hand drawing. Anyway, whenever you graph, what you want to do is label some points. Because like I just graphed, it's a little bit funky. So if I label some points, it lets the reader know what the line actually looks like. Because again, hand drawing is a little weird. All right, so let's move on. But before we do, notice that if you go from left to right, this line is going up. So it's slanting upward or rising as we go from left to right. So that's what we call our slope. So if a line rises, goes up, then the slope is positive. If the line happens to go down as we go from left to right, the slope is negative. The next thing we want to do is figure out how to compute the slope of a line. And by the end of this section, you'll see that it's very important to be able to find the slope of a line. So as we all know, there is this slope formula that we will call m for the slope. And that would be if you have points x sub 1, y sub 1, x sub 2, y sub 2, then we would use the formula that the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's always y's over x's, and the order here really does matter. So what's important, y's on top, x's on bottoms, and what also is important is if you look at these columns, we have a y sub 2, x sub 2, that's 1 point. And the y sub 1, x sub 1, that represents another point. So in the rows, y's over x's, in the columns, point and point. Now this next notation you may not have seen. It's this weird triangle with a y. I want skinny lines. So we have this weird triangle with a y, and it's actually not a triangle, that's the Greek letter delta. So we have this delta y over delta x. And in mathematics, and you will see this notation in calculus. In mathematics, whenever we look at delta, we're talking about how something changes. So this is actually read as the change in y over the change in x. And when we talk about change, look at your slope formula. The y sub 2 minus y sub 1, that difference gives us the change in the y values. And when we subtract our x's, that gives you the difference or the change in the x values. Okay, so that's just some notation that may come up. Now that we've talked about slope, we can look at the slope-intercept form of a line, which is our usual y equal to mx plus b, where the point 0, comma b is going to be our y-intercept. In example 2, we need to find the slope of the line passing through these 2 points. And then we're going to graph the line. So I could graph the line. I have 2 points, but the directions say to find the slope first. So my slope is going to be y sub 2 minus y sub 1. So I'll call this first point x sub 1, y sub 1. And the next point x sub 2, y sub 2. So if I was going to compute the slope, it would be 1/2. Well, maybe I want to move this down a little bit. That's okay. 1/2 minus a negative 1/4 over -5 minus a -2. My pen's not working really well. So let me do the math there. It's going to be equal to 1/2 plus 1/4 over negative 5 plus 2, which would be 1/2 plus 1/4 would be 3/4 over negative 3. In other words, that's going to be 3/4 divided by negative 3, or times 1 over negative 3. And we could see that the 3's will cancel and we will get negative 1/4. So I have a slope of negative 1/4. That tells me that when I do graph my line, since the slope is negative, it should go down. As we go from left to right, the slope is negative, line will go downward. Let's verify that by graphing, and we have these 2 points. We have negative 2, negative 1/4 is really close to the x-axis, and then we have negative 5, positive 1/2. So that's going to be, you get to watch me draw this, that's going to be a line that goes down as we go left to right. Sad line. Very sad line. Anyway, I'm going to label my points. I have negative 2, negative 1/4, negative 5, positive 1/2. What do you mean object is locked? It doesn't even make sense. Now in example 3, the directions are to graph the line with a slope of negative 2 and passing through the point negative 1, 1. So this time I don't have an equation. I do have a slope and I do have a point. If I were to graph the point negative 1, 1, then all I need is one more point to be able to draw my line. So I'm going to use the slope to count. When you do use the slope to count to find another point, you have to remember the slope has to be written as a fraction, and if there's a negative, you have to choose whether you want the negative in the numerator or the denominator, because a negative represents a direction. I could use the slope is negative 2 in the numerator over a positive 1, or I could write this as positive 2 over negative 1. It doesn't really matter which one you use, so I'm actually going to use both. So let's say I'm at my point negative 1, 1, and I want to use the slope negative 2 over positive 1. Well, the negative 2 is telling me that I have to, remember that's y, so I have to go in the y direction a negative 2 or down 2. So from this point, I'm going to go down 1, 2 in the y direction, and then a positive 1 in the x direction, or 1 unit in the positive x direction, 1 unit right, and then I'm at my second point. So I can simply draw my line right now. But let's say that I was using positive 2 over negative 1. Again, I'm going to start at my point negative 1, 1. I'm going to pretend like I didn't get that second point. And instead, I'm going to go up 2, because the 2 is positive. And then negative 1 means I'm going to go to the left, or negative direction in the x-axis, 1 unit. And there's another point. Notice that all 3 points line up. And that means it didn't matter where I put the negative, I would still get the same line that I'm going to attempt to draw. I don't know why I can't draw with this pen. New tip, and it's really squishy. I'm going to go ahead and label some points. I already know that this point is negative 1, 1, so let's go with negative 2, 3. So again, you can use the point that you were given and your slope to find other points and complete the graph. Well, this idea of counting is really helpful, and we'll see that later, that maybe if you have a graph but you don't have a slope, you can simply count on your graph to find the slope. But let's go ahead and go into example 4. We're going to graph the linear function f of x equal to -1/2 x plus 2. Identify any intercept, state, domain, range, slope, and 0 of the function if it exists. So we're just putting all this stuff together. What I can see from my function, remember this f of x is a y, I can see that it's written in the slope-intercept form. So it's equal to -1/2, so this would be my m, x, and it's a plus b. So I can see that b is 2. I've already got a lot of information. I already have this, that the slope is -1/2. And since b is equal to 2, that tells me my y-intercept, which would be 0, 2. So slope, -1/2. Y-intercept, 0, 2. And I can graph that point. And I can use my slope to find another point, if I'd like. Or I have an equation, I can make a table of values. If x is 0, y is 2, that gave me my y-intercept. If y is 0, x is going to be 4. So I have another point. And I could simply graph, or I could pick a third point to check my math. Usually I would use something like 1 for x, but I see that I'm going to multiply it by a -1/2. So I'm going to use 2 for x, so I get a nice integer, which would be -1. So -1 plus 2 would give me a +1. And I have my third point. Did I do my math correctly? Looks like I did. So now I can graph my line, label a couple points, so 0, 2, and I'll label the intercepts. This would be 4, 0. So let's see, we graphed the function, we identified one intercept, but in the process of graphing I found my x-intercept as well, which would be the point 4, 0. We also have to find the domain, range, slope. We already found slope, and 0 of the function. So I'm going to find the 0 first, and then we'll talk about the domain and range. The 0 is simply the x-coordinate of the x-intercept, so that would be 4. So my 0 is 4. Domain. So if we look at our graph and we go from left to right, we could see that it doesn't matter which x value we pick, it'll always correspond to the graph, a point on the graph. And keep going, no matter what x value I pick, it will correspond to a point on the graph. So my domain in interval notation will be negative to positive infinity. And the range, if I look at going from bottom to top and I pick any y value, now remember this line is going to extend on forever and ever and ever and ever, so that if I pick any y value, it will correspond to something, to some point on the graph. So it looks like we're going to get all our y values as well, which means the range will be negative to positive infinity as well. And in general, if you have a line that has a slope, either negative or positive, domain and range will always be negative to positive infinity. Again, if there's a slope that's negative or positive, domain, range, all real numbers, so negative to positive infinity. Well, in example 5, we have a graph, but we have no values. So we want to find the function represented by the graph. But we have some really nice points. If we look here, we have the point 0, 4. And we also have the point -2, 0. And these would be our intercepts. So I have my x-intercept and I have my y-intercept, which would be this 0.04, because that's where it intercepts the y-axis, which means that my b value is equal to 4. And we're going to look at the form y equal to mx plus b. And we've already found our b value, we just need to find our slope. So we have two really nice points. We can use the slope formula, or we can simply count. If I were to count, I have to be really careful that I'm looking at how the axes are labeled. Notice that these skip, like it goes 0, 2, 4, 6, 8. So each tick mark is actually worth 2 units, not 1 unit. So if I were to go from one point to the other, let's say I'm going to start at the point -2, 0, and I'm going to count 2 tick marks up. So it's a positive 2 tick marks, but each tick mark is worth 2 units. This is actually up 4. And then I'm going to go to the right 1 tick mark, which would represent a value of 2. In this particular case, because the x and y axes are both labeled exactly the same, I could have used 2 and 1, but sometimes they're not. So let's go ahead and compute our slope, which again is going to be our y's over the x's. So that would be 4 over 2, which is simply 2. So I have my slope. And now I have y equal to 2x plus 4. I have my equation. So I'm pretty much done, but remember it said to find the function. So the very last thing I need to do is just replace y with function notation f of x. So f of x is equal to 2x plus 4 would be the function that is represented by that graph. Now I counted to find the slope, but what if I were to use the slope formula, which is fine. I have 2 points. Maybe I'll call -2, 0 the x1, y1, and maybe 0, 4 the x2, y2. So if I were to compute the slope, it would be 4 minus 0 over 0 minus a -2, which would be 4 over 2. And that would be 2. So it doesn't matter if you count or if you use the formula. Now, if you don't have nice points, which are integers, so you have fractions or decimals, it's best to just use the slope formula. There are 2 special lines that we haven't talked about yet, and those would be our horizontal and vertical lines. So if you look in this box, we see that a horizontal line is going to be the graph of a linear constant function. So horizontal lines are functions. They're special functions that don't change as you go from left to right. They remain constant, which is why we call them a constant function. And they're going to take the form of f of x is equal to b. Now remember, that's just y equal to b. B is just a real number, and we're going to have a y-intercept of 0 comma b, the slope of a constant function is 0 because it doesn't change. So the slope remains stable or constant. Now a vertical line will be in the form x equal to k, where k is just some real number. The x-intercept is going to be the point k comma 0. The slope is undefined. Vertical lines are not functions. Notice that that vertical line was not written in function notation because it's not a function. In example 6, we want to graph the linear equation, and the word equation is there because we're not sure if we're going to be graphing a function or not. We're going to identify any intercepts, we're going to state domain and range, and we're going to use the slope formula to compute the slope. Now in that definition of horizontal vertical line, I already know what the slope is, but I'm just going to use the slope formula here to verify. In part A, we're given the equation y is equal to -2. I can see that this is going to be a horizontal line because it's y equal to some number. And it's very easy to graph horizontal and vertical lines. So since this says y is equal to -2, I am simply going to go down to the graph on the y-axis and put a point where y is equal to -2. And since it is a horizontal line, I'm going to simply draw my horizontal line. In the case of horizontal and vertical lines, you really don't have to label more than one point because you only need one point to graph. So this would be the point 0, -2. So I have my y-intercept, and by the graph I can see that there is no x-intercept. But let's say you didn't realize that you would be graphing this horizontal line through the point 0, 2. Well, you could make a table of values if you choose to. If you put in 0 for x, the equation says y is equal to -2. Well, let's say you put in 1 for x. Well, the equation says y is equal to -2. Let's say you put in 4 for x. Well, y is equal to -2. It doesn't matter what x is. X could be 1,000,000. Y is going to be -2. So if I were to plot those points, I would have 1, -2. I already have 0, -2 there. And then 4, -2, and so on. And then I would draw my line. So here I do have that my y-intercept is a point 0, -2. And I could see that there is no x-intercept. State the domain and range, and then use the slope formula to compute the slope. Okay, I can already see that the slope is 0 because it's a horizontal line. But what about the domain? So remember the domain, that would be all of our x values. And as we go from left to right, I see that I get all of my x values. Pick any x value and it will correspond to a point on the graph. Domain would be all, oops, don't want that. Domain would be all real numbers, or negative to positive infinity if I was in interval notation. The range is a little bit tricky. Imagine going from the bottom to the top. If I pick a y value here, it doesn't correspond to any x values. No y value touches the graph until I reach a y value of -2. So I know that -2 is in my range. But then after I'm away from -2 and I'm continuing on upward, I'm not touching the graph at all. So the range is just -2, which I expected because that's what the equation says. It says y is equal to -2, and that's it. Y cannot be anything else except for -2, and the range is your y values. So when you only have one value, we don't use interval notation because we're not looking at an interval, we're just looking at a single point. We would use our set braces around the -2. And then the last thing we want to do here is we want to verify that the slope is 0 by using the slope formula. Now I have a table of values. I can use, well, why don't I just use the first two? I'll use 0, -2, so this would be my x sub 1, y sub 1. And then the 1, -2 will be my x sub 2, y sub 2. And I'll verify the slope by using the formula, because I already know that the slope is equal to 0, because that's what the definition of the horizontal line told me. So just verifying y sub 2, which would be -2 minus y sub 1 is -2, over x sub 2, y, which is 1, minus x sub 1, which is 0. So -2 turns into a plus 2. That gives me 0 over 1, which is simply 0. And I verified that the slope is 0. In part B, the equation is x equal to -3. I can see by this equation that this is going to be a vertical line because it's x equal to some number. So I know it's a vertical line, and I know x is equal to 3, so I'm going to go on the x-axis to 3 and simply draw my vertical line. And I only need one point, and the point I have here would be 3, 0, which also happens to be the x-intercept because it is intercepting the x-axis. So right away I get that my x-intercept is the point 3, 0, and I can see that there is no y-intercept. What about the domain? Remember, the domain is all the x values. When I look at my graph and I'm determining my x values, I go to the graph and I see if for that x value, and again I'm working from left to right, corresponds to a point on the graph, but it doesn't. And if I keep going and going and going, I have nothing. Nothing, 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 nothing until I hit 3. And that would be the first x value that I have. But then after that, you see nothing, 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 nothing. So here the domain is one value. It's the value 3. I would just put that in, oops, did it again. I would put that in set braces as a set 3. The range, which would be my y values, is going to be all real numbers. Because if I look at going from the bottom to the top, and I start at some y value, and I go across, I hit the graph, hit the graph, hit the graph, hit the graph, hit the graph. So no matter what y value I pick, it's going to correspond to a point on our graph. And the range is going to simply be all real numbers. Oops, don't know why I did that. I need my interval notation, negative to positive infinity. So it's flipped from the horizontal line. So a horizontal line, the domain is all real numbers, the range is whatever that y value is. And with vertical lines, the domain is the x value, the range is all real numbers. Let's go ahead and verify our slope. And here I don't have a table of values, so I'm going to need 2 points. I could make a table of values, or I could simply pick any point on my line. I have the point 3, 0. Let's pick a nice positive point. Why don't I go with 3, 3? Now if I were to verify my slope, and I'll call 3, 0 my x sub 1, y sub 1, and 3, 3 my x sub 2, y sub 2. So it's going to be 3 minus 0 over 3 minus 3, which would be 3 over 0, and that is undefined. So I knew my slope would be undefined because that's what it told me in the definition of the vertical line, but I've just verified it by actually using the slope formula. Now if I were to write m equal to undefined, that would make no sense because you can't equal undefined. So we don't write it that way. What we say is the slope m is undefined. So why is this vertical line not a function? So remember the definition of a function says for every x value you just get one y value. So you look at the x value of 3. There's infinitely many y values, right? So right away I see that for the x value of 3, I've already have the y value of 0 and a y value of 3. So it's passed through more than 2 points. So not a function. The last thing we're going to look at in this section is probably the most important thing, and that would be what the slope actually means in terms of real-world situations. So the applications of slope is limited. In this section, we're going to look at the slope as what we call an average rate of change, and an average rate of change is simply the change of your y values with respect to your x values. Okay, so it's going to be how the y changes for each unit of x. We use the slope extensively when we compare values because look at the slope. It's a ratio, and ratios compare one item to another item, or one quantity to another quantity. So we're just comparing how one quantity changes with respect to another quantity. Example 7, we have a graph which represents a tank that is being filled with gas. So my x values are going to represent time in minutes. Y will represent the volume of gas in the tank in gallons. We're going to use the points to find and interpret the slope, which is our average rate of change. So notice in this graph, we already kind of have these 2 points. One would be the point 3, 6, and the other point would be 6, 12. So we have these points, and I can compute the slope. But in this graph, it's nicely given to me by looking at the blue lines. But let's go ahead and compute the slope anyway. So if I look at 3, 6 as being my x sub 1, y sub 1, and 6, 12 as being my x sub 2, y sub 2, the slope's going to be 12 minus 6 over 6 minus 3, which is 6 over 3, and that would be 2. Okay. And that's what we see when we look at the graph as well. Notice that if we go along the y, it's 6. So here's where I had that caution earlier about looking at the units on the x and the y axis. Notice that on the y axis, the units are going in threes. 3, 6, 9, 12, 15, 18. But when we look at the x-axis, they're single units, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we go up 2 units in y, it's actually 2 times 3, which gives us a 6. And then the y was in terms of gallons, and that gives us our 6 gallons. Now if we go a distance along the x-axis, that's a unit 3, and x is in terms of minutes. So remember, it's going to be the y's over the x's, so it's 6 gallons over 3 gallons, which reduces to 2 gallons per minute. Okay, so it's 6 gallons over 3 gallons, which changes to 2 gallons per minute. So if I was to interpret this and maybe write out some sort of sentence, the tank is filling up with gas at an average rate of 2 gallons per minute. Okay, so it's giving us this rate that the tank is filling up with gas. Another way that we can see values is with a table, and we've seen tables before. In example A, koa trees grow the fastest in the first 5 years. The following table represents the linear growth of a particular koa tree. The height in feet was measured from the 2nd to the 5th year of growth. Find and interpret the slope. So notice that this says in this problem, the table represents the linear growth of this particular tree, which means if I were to graph these points, it would be a line. So if I were to find the slope, I could pick any 2 points, and I should get the same value. So why don't I pick the nice ones? I'll pick 2, 8 and 4, 17, because they don't have decimals in them. And here my x value will represent the year, and my y value represents the height. So what we're trying to find is the rate that the tree grows per year. So the growth is going to go on top, and that would be the height in feet. The year, which would be the x value, will go in the bottom. When I find my slope, it's going to be, and I'll use x1, x2, y1, y2, 17 minus 8 over 4 minus 2. I get 9 over 2. I'm going to write that as a decimal 4.5. So remember, this is feet per year. If I were to describe this and interpret this slope, maybe the tree grows, or the koa tree grows at an average rate of 4.5 feet per, I don't know why I put a period there. Okay, I'm irritating myself. Per year. And this is worded in your own words, so it could sound a little bit different. In the last example in this section where we apply slope, there is no graph, there's no table, there's nothing. We just got words. So active users on TikTok. In 2018, TikTok had about 55 million users worldwide. By 2022, the number rose to about 1,400 million or 1.4 billion users worldwide. Find the average rate of change of TikTok users worldwide from 2018 to 2022. So this is going to be users per year. So the users are in millions. So we're going to have a comparison of million users per year, since the time is given in years. Now in 2018, we had about 55 million users. So that would represent 1 point. And I'm going to let my X values be the years and my Y values be the users. So that would be the point 2018, comma 55. In the year 2022, so that would be my X value, there were 1,400 million users worldwide. So I have 2 points. I have an X sub 1, Y sub 1, X sub 2, Y sub 2. I can go ahead and compute my slope, which would be 1,400 minus 55 over 2022 minus 2018. And I just plug that in a calculator to get 1,345 over 4. That's going to be equal to 336.25. So why don't I just round that out to about 336? And now remember, that's millions of users. So when we think about interpreting this, it's millions of users per year. That says the number of TikTok users. So TikTok users increased at an average rate of about, since I rounded, 336 million users per year. That's amazing. Increase of 336 million users per year. So it's really, we're not going to do it in this section, but what's really important about this is if you have something where you have data, where you can find an average rate of change over time, you can use that to make a prediction. So let's just say that it continued to increase at a rate of about 336 million users per year. So if that rate remains stable, then in the next year we would add 336 million users to the current 1,400 users to get over 1,700 million or 1.7 billion users. And again, if that rate continues on, we can keep adding about 336 million users per year. So anyway, that ends this section, and that's it.